All right, hello, welcome. In this video, we are going to be solving inequalities with sign charts. All right, and sign charts are something that are really important. It's something that we are going to deal with as we move on to calculus. So these really are going to be key for us. So let's just make sure that we are paying attention, and hopefully we can get a good grasp on these by the end of this video. All right, so first let's just talk about what exactly are we doing. Again, we're trying to solve some inequalities. We're trying to figure out when is a function positive, when is a function negative. So it's important to understand that in order for a continuous function, such as a polynomial function, right? A polynomial function is continuous. We can trace it with our pencil without ever lifting it up. So in order for a continuous function to change sign from either positive to negative or vice versa, when we talk about sign, we're talking about is it a positive or is it a negative? It must cross the x-axis. So we're saying if we want the y value of a function to change from positive to negative, it has to cross the x-axis. And that makes sense, right? How could I go from a point up here to a point down here without somehow having an x-intercept or having a zero somewhere in there? All right, and this is going to be really key as we set up our sign charts because it's going to allow us to split into intervals on the number line. So our question might be, well, how does a sign chart work? Before we even start, it's really important that we are getting everything into factored form. So if we have a polynomial, if it's not already factored, factor it. If we have a rational function, if it's not already factored, factor it. That's really key for us as we get ready to do these sign charts. So we start off, we just put all of the zeros on a number line. Then we're going to plug in numbers that fall on each interval. After we've done that, we'll just identify the sign for each interval. So let's say that I have my number line here. This is -4, and I'll just say it's split into two intervals. Well, I'm going to plug in -5 and see what kind of number is that giving me. Is that giving me a negative number? If so, this whole interval would be negative. If I plug in 0, let's see, what kind of value is it going to give me? Oh, well, if it gives me a positive, then this whole interval greater than or equal to -4 would be positive. All right, and then finally, we just want to use that information in order to answer the inequality and actually answer the question. So let's take a look at this first example here. We can clearly see we have a polynomial and it's factored out for us, which is beautiful, right? We don't even have to worry about factoring. That's great. So we want to know, when is this less than 0? So to start this problem off, again, let's throw everything on a number line. Okay, so I'm putting all of my zeros on a number line, and I know that at -8 it's equal to 0. And one thing I like to do is just make sure I identify my zeros, so I'm not getting confused with, well, what's my 0 and what's a number that I'm just plugging in between each interval. So I just put a 0 up there just so I remember, okay, that's a 0. Then -3 is also a 0. -3 I'll put here. And 4 is a 0. 4 I will put there. All right, great. So now it's just a matter of, let's pick a number that falls on each interval. So less than -8, I'll pick -9. Between -8 and -3, I'll say -5. Between -3 and 4, let's go with 0. Greater than 4, 5. You could pick a different number than me. That's totally fine. These are just the ones that I'm picking. All right, so if I take -9 and I plug it in, I get -9 plus 8. That's a negative number. We don't really care about the actual number as much as we care about the sign. Plug in -9 minus 4 is negative, and then I'm just going to include that that is squared, so I'll throw a squared there. And then -9 plus 3 is also negative. So now I have a negative times a negative squared, which of course is a positive, times another negative. Well, I have two negatives times a positive, which comes out positive. So this whole interval right here is positive. When we are less than -8, it's positive. For -5, all right, plug in -5 plus 8, I'm going to get a positive. -4, I get a negative squared. And plus 3, I get a negative. Well, a negative squared is positive, so I go positive times a positive times just one negative. That makes that whole interval negative. So between -8 and -3 is negative. Let's move on to 0. I plug in 0. I'm going to get a positive. I plug it in here. I get a negative squared. And finally, I plug it in here, and I get a positive. 0 plus 3 is positive. So positive times negative squared is positive times positive. Well, all three are positive, so it's positive overall. And then if I plug in 5, I'll get positive, positive squared, which is positive, and positive. So all positives, making that positive as well. So now I can see, all right, this interval is positive. At -8, it equals 0. This interval between -8 and -3 is negative. At -3, it's 0. This interval between -3 and 4 is positive. And then this interval greater than 4 is positive. So let's now use this information to answer the question, when is it less than 0? So I'm just going to call it, let's say that that function was f of x. And I'm saying, well, when is f of x less than 0? We're using interval notation. Well, it's less than 0 between -8 and -3. So from -8 to -3, and that's it. And we're not going to include -8 or -3 in this situation because at those points, it's equal to 0. So we will not include those. Say that I had changed the problem and I asked, when is f of x less than or equal to 0? Well, when is it less than or equal to 0? I now need to include all of my zeros, including this 4 over here, where it's just kind of all alone by itself. So how would I write this answer? I would say, well, it is less than or equal to 0 from -8 to -3. And then also at the point 4, because at the point 4, it is equal to 0. So I must include it. Let's do another one. Let's say, what if this, instead of asking me when is it less than 0, it said when is it greater than 0? Well, that happens on this interval here. So from -infinity all the way up to -8. We won't include -8 because it's equal to 0. Then from 0 to 4, I can't include either of those. I cannot include either of those because it's equal to 0 at, sorry, I messed up. This should be a -3 right here, okay, not a 0. So like I said, make sure that you're identifying where your zeros are because I accidentally just picked that number right there when I really wanted to go for -3 to 4. And then also from 4 to infinity, it's positive. All right on this interval, it's also positive. Again, we couldn't combine that and make it a -3 to infinity because at 4, it's equal to 0. So I can't include 4 on that interval. Let's finish it out and just say, well, what if I had given you the problem? When is that greater than or equal to 0? Well, it's -infinity to -8. This time including -8, so we need to make sure we include -8. Then from -3 all the way to 4, well then we're going to include 4 and go from 4 to infinity. So in this situation, I can now write it as just -3 to infinity because I'm going to include everything from that interval -3 to 4. And then I'm including 4 and going on all the way to infinity. So I can just smush those two together, right? It doesn't make sense to break it up and write it as -3 to 4 and 4 to infinity if I'm including the 4. So I can just smash that together, make it -3 to infinity. All right, so this is with a polynomial function. Let's now do one with a rational, okay? So now we've got a fraction in here. So what about for rational functions? Well, it's important to understand that they can change sign at both zeros and at discontinuities now, and more specifically at our vertical asymptotes, our infinite discontinuities. So moving from polynomial functions now over to rational functions, well, we just want to add on discontinuities to our sign chart. And it's important that we differentiate between the two on our sign chart, because if someone asks us, oh, when is this function greater than or equal to 0, we want to include the zeros, whereas we would not want to include the discontinuities. So it is important that we distinguish between the two. So let's try this problem here. X minus 6 times x minus 5 over x minus 3 is greater than or equal to 0. So we already have it factored. Let's just get this on a number line. So here's my number line. And I'm going to put 3, 5, and 6 on the number line. So 3, 5, and 6. And again, it's important to distinguish which of these are zeros because we want to make sure we include those. So let's see, x equals 6 is a 0 and x equals 5 is a 0, because we want to include those in this situation. It's greater than or equal to 0. So we're going to include those. We're not including x equals 3 because it's undefined at x equals 3. So no matter what, we will have a parentheses on that x equals 3. So now let's just plug in some numbers. I'll plug in 2, I'll plug in 4, and I'll plug in 5.5. All right, again, it doesn't really matter what values you choose. If I plug in 2, I'm going to get a negative, and a negative. Okay, for all three of these, I get a negative. 3 negatives makes it negative, so I'm not including that interval in my answer. Plug in 4, I'm going to get a negative times a negative in the numerator and a positive in the denominator. Well, 2 negatives and 1 positive makes it positive overall because I have an even amount of negatives. Plug in 5.5, that gives me a negative, a positive, so that's negative overall because I have 1 negative. And then, oops, I forgot. I got to plug in 7 here. So 7, I plug that in. I get positive, positive, positive. So it's positive overall. Now it's just a matter of answering my question. So when is it greater than or equal to 0? Well, greater than or equal to 0. From 3 to 5, we want to include the 5 and not include the 3. Okay, include the 5, not the 3. So from 3 to 5, bracket on the 5. And then we'll include 6 because 6 is also a 0 all the way up to infinity. So from 3 to 5, 6 to infinity. Say that I had changed that problem, and let's try a less than or equal to 0. Okay, we'll just do less than or equal to 0 for this one. So less than or equal to 0, well, that's going to be from negative infinity up to 3. We're not including 3 because, again, it is undefined there. It's not equal to 0, it's undefined. So from negative infinity up to 3, not included. Then from 5 to 6, including both of them because it's equal to 0. At both of those points. And then that's it. The rest of the intervals are positive. All right, so I hope that this video helped. Another thing that you could do, and a way that you could check your answers, especially with these polynomials, is maybe instead of using a sign chart, and I would suggest using the sign chart, but it's also important that we're able to interpret the graphs. Okay, if I were to graph this, let's see, I've got an x-intercept at -8 over here. I've got an x-intercept at -3 here. And I've got an x-intercept at x equals 4. So it's an x to the 4th. So if I were to sketch it, I would come up, I'd cross through, and then I would not cross through at x equals 4. So if we look at, well, when is this function less than 0? It's less than 0 on this interval right here from -8 to -3. We can clearly see that on the graph. All right, when is it greater than or equal to 0? Well, from x equals -infinity to -8. Then from, I'm actually doing the greater than or equal to 0 right now, sorry. Greater than or equal to 0 from -infinity to -8. And then for the whole rest of the graph. So -infinity to -8 and -3 to infinity. So it's kind of cool kind of seeing this come together and how does this sign chart work. All right, so I hope this helped. Good luck as you get going on